For centuries, Betelgeuse has burned above humanity as a restless crimson beacon perched on the shoulder of the Orion constellation. Its deep red glow, visible even to the naked eye, has made it one of the most recognizable stars in the night sky. Ancient civilizations tracked its shifting brightness with careful attention, weaving it into myths, calendars, and celestial maps that guided early navigation. Sailors once used its position to cross vast oceans, while desert travelers aligned their journeys with its steady presence above the horizon. Over time, Betelgeuse became more than just a point of light. It became a symbol of cosmic impermanence, something massive, ancient, and yet unstable. At roughly 1,400 times the radius of our Sun, it is not simply a star but a supergiant structure so vast that its outer layers would engulf the inner planets if placed in our solar system. For decades, its behavior puzzled astronomers. The brightness did not remain constant. Instead, it shifted, flickered, and dimmed in unpredictable cycles. Then, in late 2019, something unprecedented occurred. Betelgeuse began to fade dramatically. The dimming was not gradual. It was rapid enough to be noticed even without telescopes, triggering global scientific attention. Within weeks, its brightness dropped to nearly one-third of its normal intensity, an extraordinary change for a star once considered relatively stable. The astronomical community immediately mobilized. Observatories across Earth and space redirected their focus toward Orion. The central question emerged with urgency: was Betelgeuse approaching a supernova, the explosive death of a massive star? If such an event occurred, it would be visible even during daylight, briefly outshining the Moon and becoming one of the most dramatic celestial events in recorded human history. Telescopes around the world worked in coordination, gathering light curves, infrared data, and spectral readings to decode the cause of the dimming. What they discovered was both surprising and unsettling. The star was not simply fading from collapse. It was expelling enormous amounts of material into space. A massive cloud of dust formed around it, temporarily blocking its light and creating the illusion of a dying star. This was not immediate collapse. It was a violent phase of stellar instability, revealing the true nature of red supergiants in their final evolutionary stage. Betelgeuse is a star living on borrowed time. It has exhausted hydrogen in its core and now fuses heavier elements in layered shells. Unlike our Sun, which will remain stable for billions of years, Betelgeuse is in the final, chaotic chapter of its existence. Its internal structure resembles an onion-like layering of fusion zones, where different elements are forged in successive shells. Deep within, iron is accumulating, a critical turning point in stellar evolution because iron fusion no longer produces energy. It consumes it. When the core can no longer sustain itself, gravity will win. The star will collapse, triggering a supernova explosion of immense power. Before that final moment, however, the star undergoes violent instability. Massive convection currents churn beneath the surface, driving eruptions and mass ejections. These processes create enormous clouds of gas and dust that drift outward, forming a dynamic and constantly changing stellar environment. Betelgeuse is not a smooth sphere. It is a boiling, shifting mass of plasma with surface regions that brighten and fade over weeks or even days. Modern observations reveal that its surface behaves like a turbulent ocean of energy, driven by forces far more extreme than anything seen on Earth. Gigantic convection cells rise and fall across its surface, some spanning distances larger than the entire orbit of the Earth around the Sun. These massive structures are responsible for its irregular brightness and unpredictable behavior. The expelled material does not simply vanish. It interacts with surrounding interstellar space, forming shock waves and glowing clouds of energized gas. In some regions, this interaction compresses gas enough to trigger the birth of new stars, linking death and creation in a continuous cosmic cycle. Every eruption from Betelgeuse contributes elements such as carbon, oxygen, and iron into the galaxy, the same materials that eventually form planets and life. In this sense, the star is not only approaching its end. It is actively shaping the future of cosmic evolution. The dimming event of 2019-2020 became one of the most studied episodes in modern astronomy. It revealed how dust formation and surface activity can dramatically alter the apparent brightness of a star without signaling immediate collapse. This discovery forced scientists to refine long-standing models of stellar evolution, particularly for red supergiants nearing the supernova stage. Advanced observatories revealed that Betelgeuse's atmosphere is not uniform but structured, with immense turbulent regions constantly shifting and evolving. These regions generate powerful stellar winds capable of ejecting vast quantities of material into space. Each observation provides a deeper understanding of how massive stars live, evolve, and eventually die. Beyond its scientific importance, Betelgeuse holds symbolic significance. It represents the fragile balance between stability and chaos in the universe. It reminds us that even the largest and most powerful objects in existence are not permanent. They too are part of a cycle of transformation. The iron forged within its core, the oxygen created through fusion, and the carbon produced in its final stages will eventually be scattered across space. These elements will later become part of new stars, planets, and potentially even life itself. In this way, Betelgeuse is a cosmic contributor to existence, recycling matter across billions of years. If it were to explode during human civilization, the supernova would provide an unprecedented opportunity for scientific observation. Neutrino detectors on Earth would register the first signals of core collapse before any visible light reached us. Gravitational wave observatories could detect ripples in spacetime generated by the violent collapse of the star's core. Space-based telescopes would then observe the expanding shockwave and the formation of heavy elements in real time. Such an event would allow humanity to witness stellar death at a level of detail never before possible. Even today, Betelgeuse continues to be monitored closely. Subtle changes in brightness, temperature, and spectral emissions are carefully tracked. Each new dataset refines our understanding of how massive stars behave in their final stages. The star serves as a natural laboratory for studying extreme physics, gravity, nuclear fusion, and plasma dynamics operating at unimaginable scales. Despite centuries of observation, Betelgeuse still holds mysteries. Its unpredictability ensures that no model fully captures its behavior. It remains a reminder that the universe is not fully known, and perhaps never fully knowable. As it continues its slow, unstable evolution, Betelgeuse stands as both a warning and a wonder. A reminder that even the most massive stars are temporary, and even destruction can become creation. And so, above Orion, the red supergiant continues to burn, flickering with the final energy of a star preparing for its last great transformation.